Okay, let's continue. Next, number 4, it is to find the general solution of the differential equations. So this is linear equation. Here, firstly, you need to multiply by x squared both sides of the equality, and here you get y prime plus 3xy equals to x cubed. Yeah, and to solve this linear first order linear differential equation, so you will solve here. You will find here solution of the homogeneous equation and non-homogeneous equation. Yeah. So to define here homogeneous equation, solve the next equation 3xy equals to 0. Yeah. And what we have here, so y prime equals to minus 3xy. So here dy divided by dx, which is gives us minus 3xy. It is separable variables, and then dy divided by y should be equals to minus 3x dx. And then here we have now natural logarithm of y equals to minus 3x squared divided by 2 plus constant. And now to define y here, what should we do? And y here is equals to e to the power of minus 3x squared divided by 2 plus constant. And now we are considering this constant. It's like we can continue and write here e to the power of minus 3x squared over 2 multiplied by e to the power of c, where it will be again in another constant. So we can define it like c1, and c1x we will define it and put to the given equation here with right side, non-homogeneous one. So, and here define this c1x, it will be particular solution. So as you can see here, we have this one. I mean, in d1 it's correct here. Yes, it's written. So this one we got here c times e to the power of minus 3 over 2x squared. Now we need to find here this particular solution, this one. Is it clear? Put to the let me write here, given equation, it will be now minus so here you can see your particular solution yp now has the form e minus 3 over 2 x squared multiplied by cx. And here y prime, what will be y prime in this case? So it is e to the power of minus 3 over 2x squared multiplied by, so it will be 2 are cancelled, minus 3x, yeah, am I right? Multiplied by cx plus c prime x multiplied by e to the power of minus 3 over 2x squared. Do you understand me? This is the derivative of the product. And now put to the given equation again here. So after putting, there is something canceled because you can see here we have minus 3x, but here we have plus 3x. So we need to just add this one. Let me clear this part. let me don't write this one and just continue here. So here it will be now plus 3x times e to power of minus 3 over 2x squared times c of x. Yeah, so you can see they are cancelled. This one with this one. Is it clear? It should be cancelled. And it's equals to x cubed. So, and now we need to find here c prime x. So, and a c prime x here. What is c prime x now? C prime x, it is equals to now x cubed multiplied by e to power of minus 3 over 2x squared. Is it clear?
Yes.
So, and now find c. So to define c here, just integrate x cubed e to power of minus 3 over 2x squared dx. That's it. After integrating, you get here this kind of value expression. How to integrate, you know? You can use your integration by parts. Okay, I think now it's clear. Any questions here? Is it clear how to solve linear differential equations? First order.
Yes, it's clear.
Okay, number 5, we'll skip consider the function and derivative of the function. I think you know how to find derivative. There are using table, you can easily find your derivative. There are no problem. Okay, now decide which one of the following statement is true. So here you need to check each of them. So here again, we are using limit. This ratio x tends to c, f of x divided by g of x. And which is equals to L, if L, any finite value, it will be big O. If L equals to any finite value, it means that which is not 0 and 1 here, because for 0 and 1 there are special cases. If L equals to 1, it will be equivalency, and we denoted it by this one, yes, equivalency. If L equals to 0, it will be small o. So we can write here, if L, if there exists any finite limit L, we can write f of x equals to big O of g of x, because it has biggest order than f, it means. So if L equals to 1, it will be f of x equivalent with g of x. If L equals to 0, it will be smallest order, yes? Like this, small o. So you need to check each these versions starting from B, C, D, E, and you obtain here correct statement. So, for example, number in E1, so this is true one. So let's check this true one, for example. And when you check it, what do you get here? So your G is now this one, your F is this one. So limit as x tends to infinity. So 1 over x cubed. Here we have square root of x6 power plus 1 minus cubic root of x cubed. So what should you do here? If you put infinity, you get here 0 over 0, yes? And what should we do here?
We can divide it to like the greatest power.
Mm-hmm.
It will be x cubed. Each of them we can divide it to x cubed.
Mm-hmm. Then?
And since x tends to infinity, we can get rid of module. It will be just x cubed.
Mm-hmm.
And we get or we can use L'Hopital's rule.
Maybe. But here I think the most useful way here is just multiplying and dividing by conjugate. Numerator, I mean.
Mm-hmm.
So here we need to multiply square root of x6 plus 1 plus x cubed and divide by it. So then you can see here in top we have x6 plus 1 minus x6. They are cancelled. It will be just 1. Do you understand me?
Yes.
And in denominator we get here, look, in denominator here we get this one. If we continue, we just divide it and multiply it. So you get here limit as x tends to plus infinity 1 over, so this one plus x cubed multiplied by 1 over x cubed, yes? And then we can cancel by x cubed, this denominator. You can see, because here the greatest power is x cubed, yes? We just divide it. So, and what we have here? 1 over 2, yes? Because 1 plus 1. Do you understand me? Here
Yes.
x6. Here x6 because of here. So it's 1 over 2. In denominator here we have, I mean, just 1 plus 1 in denominator 2. The answer will be 1 over 2. That's it. So that's why here you can see we have finite limit. L is 1 over 2. So the correct statement will be E1. So here it will be big O. Is it clear? So by the same way, you need to check each of them. Of course, you don't know the correct answer. You need to check all of them. Here, we just know the correct answer. That's why we can just check the last one. For example, the correct one only. Any questions here?
No.
Okay. If no, let's move to the next. Number 7. You need to hurry up because you have another session, chemistry, after this session. So consider the subset of the real line. Decide which one of the following is true. So here, find supremum and infimum of this set. So what is supremum? Least upper bound, it is supremum. Greatest lower bound, it is infimum. So here you can see the first one, where it tends as n tends to infinity. What kind of formula is it? What was it? Fundamental limit, yes? It is fundamental limit. And it tends to, as n tends to infinity, it tends to number e. So the greatest value here is number e. And here, the least value, minus 1, the greatest one is 1, yes? It depends on n, of course. But the least one here is minus 1, the greatest one is 1. So here you get the S as a least value minus E. As a greatest value, just E. And now, so we have here least and greatest values. And sine pi n over 4, what will be the least value here? Pi n over 4. Who knows?
1 over under the root over 2.
With minus. Least one will be
Yeah.
minus 1. Yes, minus. The least one will be minus square root of 2 over 2. And the greatest one here is?
Plus square root 2 over 2.
No, the greatest one is 1.
Yeah.
The greatest one is 1 here. So you can see, if we add the least one to the least one, here will be minus E minus square root of 2 over 2. This is infimum. And plus E plus 1, it is supremum. The same is the C1. You can see. Is it clear?
Yes.
Okay. So next now, find the incorrect statement of the following sequence. So I will send this file also, okay, to the group with these notations. So find the incorrect statement of the following sequence. So here we need to find limit of the sequence, okay? So it's given x and sequence. How to find here? So here you need to put again beta. So beta is parameter here. Define with respect to beta. So what should we do firstly? Find the incorrect statement of the following sequence. So incorrect statement we need to find here. Incorrect statement. So we can check each of them. For example, beta here is 1. If beta is 1, look, if beta is 1, it will be 1 over e to power of square root of n plus 1 plus n. So here, what should we do? Just, again, you can just multiply and divide by the conjugate to the power. Okay? Because of here, as n tends to infinity, it tends to infinity minus infinity. The power, I mean. And after checking, do you understand me, students? So here we have,
Yes. Yes.
we need to multiply and divide to the conjugate, and it will be n plus 1 square plus n power of beta minus n square. Yes, here n square and n square are cancelled. That's why here it's written beta greater than 1, beta less than 1. So it depends on the beta, of course. So, and divide by this one, n plus 1. This is power just. Square plus n beta minus n plus n plus n. So here you can see it is e power. As n tends to infinity, if beta greater than 1, look here, if beta greater than 1, it tends to infinity. Do you agree? Do you agree with me? Why it tends to infinity? Yıldaşova joined us. Yıldaşova, I have asked it here. If beta greater than 1, this value tends to infinity. Is it correct?
Yes.
Why?
Because n tends to infinity.
And tends to infinity, and power will be greater than 1. Yes, here. So here you can see n square and n square are cancelled after opening the brackets here. It will be n square plus 2n plus 1. So n square are cancelled. So you can see here, it depends on beta now. If beta is greater than 1, so you can see that this is tends to infinity. So the B1 is correct. If beta is 1, now, if beta is 1, look, if beta is 1, what we have here, as the greatest power, we have now, so here we have 2n after cancel, 2n plus n beta divide by this one, yes? So the numerator, if beta is 1, it will be 3n. So, and here, if beta is 1, what we have here now? So 3 over 2 here we get. Here we have 2 now. So you have e 3 over 2 divided by, multiplied by 1 over e. So what is it now?
E power 1 over 2.
2? Yes, A is also correct. So it means. And now we have, so the E is not correct now. So none of them may be correct. Now we need to check C1, last one. So beta less than 1. Beta less than 1, where it tends now? It tends to 0 now.
Infinity? I mean,
it
yeah.
tends to 0. It tends to 0. So it will be 1 over e, just not square root of e. So that's why it's not correct. We need to find incorrect statement here. A and B are correct. It's correct. A and B are correct. It's correct because you can see A and B are correct. It's correct statement. So the incorrect statement here is C1. Okay, let's finish with this sample. Number 9. Now let A and B real numbers. Decide which one of the following statement is true. So here we have inequalities. We need to check each inequalities again and find correct one. Yes, here correct one. How to check them? You can use here derivative.
L'Hopital's.
L'Hopital's? Why L'Hopital's? Not number 10, number 9. So here in number 9, we can use here derivative to check these inequalities. using, if you know, here there was main theorems of the differentiation. So there was Lagrange, Fermat, Cauchy, yeah, Rolle's theorem. So we need to use these theorems and check the inequality. We can use here these theorems. Okay, I will send this solution, number 9, to the group. And number 10 here. The limit. How to find here limit now?
L'Hopital's rule.
Of course, we can use L'Hopital's rule here. It will be very easy now. But also we can use here just multiplying by conjugate and do other works. Yes, but here the most easiest way here is I think L'Hopital's rule. And if you use L'Hopital's rule, it will be in denominator we get 1, yes. In numerator we have here because of here 0 over 0 you get. So in denominator here we have it is 1 over m 1 plus alpha x power of 1 over m minus 1 minus 1 over n 1 plus beta x 1 over n minus 1 and multiplied by alpha here multiplied by beta. Yeah. And now you can put instead of x 0. So if you put 0 here, it will be just alpha. You can see alpha over m minus beta over n. That's it. Is it clear?
Yes.
Okay, very good. So here we consider the function, find domain, asymptotes, monotonicity, concavity, convexity. I hope you can do it. So because it takes time. It takes time. And here, second order differential equations with right side. So here again, we need to find homogeneous one using characteristic equation. What will be characteristic equation here? Lambda square minus 2 lambda minus 3 equals to 0. Yeah. And here lambda 1 equals to 3 minus 3 and 1 here. Yes, minus 3 lambda 2 equals to 1. So your solution here, the homogeneous one here is y0 will be now e to power of c1 times e to power of lambda 1x plus c2 times e to power of lambda 2x. So you can see here we have the result c1 e to power of minus 3x plus c2 e to power of x. And now this is y0, but we now we need to find here y prime, y particular. Y particular, you need to find what we have in our lectures, how to find this y particular. There was special cases, this omega, sigma, yes, depending on these parameters. Can you continue it? In your notebooks, you have this kind of examples. So you can solve and send to the group. I will check it, okay? This exercise.
Okay.
So just find here y particular. Y0 have already found it. Find now y particular. Okay. Any questions now? Regarding the examples. So this kind of advising hours will continue, I hope, on the next week also, but in offline format now, I hope so. And it will be better than online, of course. So, and there will be schedule again, when and with which professors he will provide advising hours. So do not hesitate if you have any questions, any comments, write to the groups. We'll solve together, okay?
I have one question.
Okay.
Limit x tends to 0.
Just a moment. Just a moment.
Mhm.
Yeah. Limit.
X tends to 0. In brackets, a to the power of x minus ln a to the power of x.
Like this?
Yes, divided by b to the power of x.
B.
And natural b, yes, and natural logarithm b to the power of x. And this all in brackets and in power 1 divided by x squared.
Like this, you mean?
Yes.
Here in denominator, is it correct denominator bx multiplied by ln bx or minus?
No. Not multiplied, minus.
Minus,
Bx
yes?
minus. Yes.
So we can just simplify this one. Limit as x tends to 0, ax minus x, natural logarithm of a, bx minus x, natural logarithm of b, yes? Do you agree?
Yes.
So x tends to 0. What can we do here? So you can use here fundamental limits, of course. You can use here fundamental limits and consequences of the corollaries of the fundamental limits. So if you put here 0 instead of x, you get here you cannot get something. No, you get here 1 power of infinity, yes? So it leads to the e now. It leads to e. This is from sample, Joshua?
Yes.
Which year?
I couldn't find, but it's from samples.
Okay. Okay, so I will send it to the group, okay? The solution here.
Okay.
I will send to the group because now we don't have some time here. It's just finished now. Okay, any other problems? Do you have any other one? Yeah.
Ask where we can find this videos of these lessons.
Videos.
Yes.
I don't know really, because of I have recording videos of this one, but I have not solved yet where to put this kind of videos. So maybe to Didactica or maybe to just Telegram group, or just LMS, for example. Do you have LMS or you don't have LMS? I think you don't have, yes?
Wait, I don't know.
Okay, so I think we will put it to the Didactica portal. Or it will be useful if you put it to the Telegram just. Which one is for you comfortable, for example?
Can you put it to Telegram?
Okay, let's do it. I will put it to my YouTube channel, okay?
Okay.
I think it will be greater.
Mm-hmm.
So I will put all these video lectures just in one playlist. Do advising hours on mathematical analysis 1 in 2023, and just put to the my YouTube channel, but not now. It takes time, of course. I will do it during this day. Okay.
Okay.
Okay. These three sessions I will put. I mean 3 days sessions. Okay. Any other questions?
May I ask if the samples from iExam are very similar to our future?
I don't know, really. I cannot answer to this question.
Because here is exams in written form. In written form in 2020,